Okay, there's a few basics that I want to cover. So it's not necessarily just graphical, but just some miscellaneous basics that we're gonna look at. So let's select everything that's on your screen, and let's press Control E and disable them. So we don't want any distractions on the screen right now. So let's look at a few different data tree manipulations and lists and such. Okay, so the one we're going to look at is shift list. So what shift list does is, let's just hover over it and have a look. It offsets all items in a list. So for example, let's bring out a panel, and I'm just going to use this as an opportunity to show you some other little tidbits. So when you double click in a panel, you can type all kinds of text. But let's say if I want this to be sort of like structured data instead of just one line text, you can right click on the panel. So right click and select multi-line data. I'll wait for you guys to catch up. Select multi-line data. And now you'll see it starts to put things in like a numbered sort of way. So it turns a panel, basically turns a panel into a list, right? So let's turn this into, like, let's say 1, 2, 3, 4, 5, 6, 7. We'll just leave it at that. Let's put this into list. And then let's see what comes out at the end. So if we put panel here, what you'll notice is you'll see that it shifts the list. So over here on the left side, at index 0, you had 1, but now at index 0, you have 2. Right? So the list has been shifted up. And then the first one, which was 1, is now at the end. So it's kind of done a bit of a rotation. So you can also define how you want the list shifted. So for example, let's say if I wanted to shift by, let's just put 0 dot 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 2 dot 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 10. Right? So if we go 2, you can now see that 2 is now at the bottom and 3 is at the top. Okay, so that's shift list. Now let's look at list item. I think you guys should already know about this one. But if you have a list, you can select an item using this list
Oh
item.
my God, they're typing so much.
Excuse me,
Me?
Zurnab, you have a question?
Sorry. No.
Okay, so list item, and then let's go 0 dot 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 2 dot 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 dot. Our index goes from 0 to 6, so we're gonna go take it to 6. Have a panel at the end. And then as you move your slider, you can see that it picks from the list. Any questions on any of this so far? This is just basics in Grasshopper, little things that you should know. Okay, the other thing we're going to look at is concatenate. So let's say concatenate. So let's hover over this. What does this do? Concatenate some fragments of text means it makes them join together. So for example, the first one, let's go hello. And then for the second one, we type world. And then what you see at the end is hello world. All this is doing is joining text. So when you're, for example, you're adding tags to faces, when you're adding tags to meshes, to poly surfaces, like if you ever need to annotate something in Grasshopper, you can use concatenate in addition to things that you're getting, from example, from a point list, and you can combine it to make it do things. So for example, in this one, I can add a space before world. And yeah, you can, just kind of make it a bit more legit. Any questions on this? This is just super basic stuff. Okay, what I want to try and do is see if we can visualize what shift list can do for us. So let's make a circle, base plane and radius. So in the circle, the plane, we're going to leave it as X and Y. We have radius, which is 1, and then let's see. Let's bring in divide curve. Put circle into curve, and it divides into a bunch of points. And let's move the circle up. Can anyone guess what goes into motion if I want to move it up?
You're going to have to define the axis in which the geometry moves on. So you're going to need like a component X, Y, or Z.
That's right. Thank you, Jack. Yeah, so you put Z because we want to move up, and then let's add a factor in here. So currently it's got 1. Where is this going? Yeah, okay. Well, I have to add the geometry. So yeah, we add Z, and then we put circle into geometry. And then you can see that it's moved up here. Okay, here's a little trick. Now, let's say if you've lost your geometry in Grasshopper and you want to zoom into it. You can click the component, which in this case is move. You type Control and Shift just once. So press Control down and just tap Shift. Sorry, not Shift, your space bar. So Control down and tap your space bar, and this thing will come up, and then release Control and space bar. And you see this little button here. It says Zoom. So it means zoom to preview geometry of all selected objects. So it will zoom into the object that you're trying to highlight. Okay, so let's also add a divide curve component with this one. And then this time, actually, before I do that, let's go line. So we're going to create a line between 2 points. So select this one. There's a bunch of line components. We're going to select this one. So you go start point from one of them and end point on the other one. And it just creates lines. So now let's use shift list. Take your points and put it into list. And then replace one of them. So either start point or end point with the output from your list. And you see what that does. So here you can visualize basically how the list is shifting. So let's just add a number slider, 0, 5, 10, just randomly in your shift. And then here, as you shift your list, you can see this geometry, how it changes, because it shifts the points that are used to build the line. Does that make sense to everyone? Anyone not get this? Let's just use that. Okay. Hopefully everyone got that. Yeah, and then you can do, some more fun things here. For example, now we can take this slider bar further up. You can increase the height here if you want. You can shift your list and it creates, these interesting geometries. You can even scale your circle a little bit. So let's just say I'm going to separate out this circle, put this into geometry instead. So you have a separate circle component. And now I can affect the radius. So 0, dot, 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 0.5, dot, 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 1. And now you can create columns this way, parametric columns. You can affect your upper radius, your lower radius, if that's what you want to do. Let's just actually increase this value. Let's stick it to 15. No, so 2. Yeah. Any questions? I'll try to keep an eye on the chart. Just let me know if anyone has any questions.
I was wondering, could you make your grasshopper screen just a little bit bigger? It's kind of hard to see with like split screen if we're doing it one monitor.
How's that?
That's fine. Yeah.
Something else that's really useful is to know sometimes how long a list is. So instead of, having to count the number of objects in a panel, you can just use something like list length. And if you put a panel in front of that, it gives you how long the list is. Basically, how many objects or how many, items are there in a list. It gives you the length. So this is useful, especially when you get into math and divisions and multiplications and you need to affect geometries. This is especially useful when you start doing things like attractors.
Okay, this might be a stupid question, but what if it's not a circle and you just have a line and then you shift your list? Where does the line go that doesn't have like a point to shift to? Does that make sense?
Your line's not going to go anywhere. It's mostly to shift items in a list. So unless there is something happening, in a list, that's what would happen. So that's why I did divide curve to divide the points on this curve, and then I can shift those. But if you try to do shift list to line, I don't think it's going to do anything. We can try it. Just It doesn't really do anything. It's just got one thing. It doesn't really have anywhere to shift to. So the input will equal your output in this case. But if you divide, points on your line, like how we did here, divide curve, and then you shift the list on that, it basically just shifts the order of the points in the list, right? So if you look at this, all it's doing is it's not really moving the curve or doing anything. If you look at this one, all it does is it shifts the order of the points, like the index of each point in the list. Does that make sense, Jelena?
Yes, thank you.
Thank you. Okay, I want to look at something very quickly and then we'll go on break. So this was basically shift lists and some miscellaneous stuff. Okay, I'm just going to select all of this and hide it. Okay, let's create, let's see. We're going to create cells. Okay, so let's start with hexagonal cells. So let's look at where this came from, because this is actually really important to know for you guys as you make progress with Grasshopper. So if you press Control-Alt, keep it pressed down and click on hexagonal cells, you'll see in vector, under grid, there's hexagonal, radial, rectangular, square, triangular. So there's all kinds of grids that you can populate. So what it generally gives you by default is a plane, and you can see this like grid-like plane here. So in this case, it's an XY plane. And it gives us points. So it gives us these cells and these points. But we have to use something to separate the cells from one another. Currently, I'm not just able to take each cell the way I want it. So we have to do some data tree manipulations. So let's use a component called data. So this is a generic component in Grasshopper. It contains a collection of generic data. So you can put cells into this. And then coming out of it, it shows it's got, 25 items coming out of it. So how do we start to manipulate this? So let's go, we're going to use a new component today called explode tree. So we put the data in here and it separates out the branches. So this is giving us an error. So let's see what it's saying. It says contains more branches than this component has output parameters. So the output parameters are 3 branches. So let's see what we're getting here in terms of the branches. So coming out of data, 3 branches. 1, 2. So all I did was I looked at how many branches we have in here. So we have 1, 2, 3, 4, 5. And another way to look at is using our param viewer. We double click this. And here you can see, so 1, 2, 3, 4, 5. So I increased this to 5 branches. And the first one is always the way Grasshopper reads it. It starts with 0. So you have 000 and then 001, 002, etc. So now let's say I want to visualize how things are coming out in my explode tree. What is the difference here? So let's see. We're going to add just a panel. So this first one, let's compare it to the original, is giving us just the first branch. So if I add another data component here, you can see how it's giving me this first column of cells. And then if I go make a copy of the data, add the second branch into it, that's your second one, third one, fourth, and fifth. Right, so this is a way for you to actually start to separate cells and mesh faces using Grasshopper. Any questions so far?
Hello? Hello?
Hi.
Yes, so my explode tree only has 2 and it's telling me it contains more branches than output parameters. I was wondering how you got the 5 on there again.
So just press this plus button.
Oh yeah, thank you.
Yeah, no problem. Okay, so a way to visualize all of these cells, I'm going to go into my top view, so everyone knows. You can use area, oh, here, area. It's coming out of cells, actually coming out of data. And the area component gives you the centroid and the actual area. So always remember the area, like whether you use mesh area or whether you use, this one, which is for NURBS, so surfaces, this is going to give you area and a centroid of your area. So here I can use point list and put centroid into points. I'm going to hide my area components, so preview off. And if you zoom in, you can actually see, and let me just actually increase the size. So this is size 0 dot 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 0.005 dot 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 1. So here you can actually visualize the index numbers of all the little cells that you have here. Okay, so this is just to visualize directly coming out of data. So I'm going to put this aside. I'm going to select these and hide them. So Control Q. And let's look at some cell manipulations. So let's go into tree branch. So type tree branch. So this retrieves a specific branch from a data tree. So we're going to put the tree in here and it's giving me an error. So it's saying input parameter path failed to collect data. So what I'm going to do here is I'm going to go 0 dot 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 2 dot 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 5. It's not working. It says path 2 does not exist within this tree. Why is it? Path. Let me try something. Try simplifying the tree. Okay, that worked. So when I simplified it, now it's taking my information. So what is the difference here? So let's look at it. So this is my param viewer from the original. And then I'm going to add param viewer from simplified tree. And all it did was it removed, if you guys can remember, simplified data tree by removing the overlap shared amongst all branches. So the overlap here is this 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and all I'm left with is 0, 1, 2, 3, 4. So that's kind of how tree branch will work. It will give you, it works with a bit more of a simplified version of your data tree, and it will give you the information that you need to be able to select from the branch. So now here I have just this branch. So it is giving me curves. So if I go geometry, it gives me, and if I hover over on the right side, polyline curve. Now I can turn it into a surface. So type boundary surfaces. And now it turns it into a surface. But there's one little trick, which I don't know if this is going to work actually. I'm just going to try it. If we use a surface component out of geometry, I'll hide my boundary surface. Yes. So if you just use even a surface component, it'll turn it into a surface coming from curves.
Is there an advantage to doing it either way?
No. You can use either.
Sounds good.
Okay, and the last one for today for data trees that I'm going to show you is called flip matrix. So you bring your data component into flip matrix, and also just for simplicity, just hide the surface that we created before. So select it, Control Q, flip matrix. And then let's have a look at the point list coming out of this. So we're gonna go area, point list. We could have copied it over from the other side, but we'll just make this new one. I will bring centroid points. I'll bring the slider bar over from the other one. The size, hide area, so it's not confusing. And now if you press this point list, you can see how 0 goes in a column. 1 goes in a column, 2 goes in a column, 3 and 4 as well. And then let's go to the other point list. Hide the one coming out of flip matrix. Let's look at the other one. And you can see how 0 goes in the right direction. So it's not in the column, it's in the row. So 0 is a row, 1 is a row, 2 is a row. So flip matrix is a way to flip the direction of your matrix. Any questions?
I'm getting an error on my point list that says data conversion failed from number to point.
Do you want to share your screen and show it to me?
It says host has disabled screen sharing.
Okay, go ahead now. You're putting area into points. You need to put centroid into points.
Ah, okay, lovely. Thank you.
No problem. Okay, any other questions? Okay, if nobody has any questions, let's take Let's take a very small break, not too long, please, because we're gonna need the time. It's 11:46. Let's come back here at 11:50. And all you guys should do is this is basically a few minutes for you to fire up this model that we did here. So I think this is the one that let me just pull this up. This is the one that Raymaline would have showed you, I believe. This one here. Does everyone remember this? Or I guess do you have it?
Real quick, was this just the surface evaluation tutorial?
Correct. Yeah,
Gotcha. Okay.
that's the one. So
Just
just
trying to remember
yeah,
what I
just
named my files.
yeah, that's the one, the surface evaluation with the simple pavilion. It was, I think Raymadine also shared the recording I made for her for that tutorial. So you can just load this model, and I'll give you about just take about 5 minutes, load this model, and then we're gonna do a few more manipulations on this one. Thank you. Okay, hi everyone. So just in this file, I'm not sure if everyone has it yet, but can you bring in this model here? If you don't have it, please tell me because I can show you how to bring it in fairly quickly.
Yeah, I kind of crapped the bed on file management here. I cannot seem to find it.
Okay, no worries. So let's bring this model in. So let's go into Blender. This won't take very long, actually. Let's go into Blender. I'm just going to assume that nobody has, the models that we worked on. So let's just make a plane. So Control A, Mesh, Plane. Let's make the size 10. Okay. Make size 10. So here's the plane. I'm just going to move it over a bit. Let's go into edit mode, loop cut. We've done this a bunch of times, so this should be fairly quick for everyone. If anyone has issues, just please stop me. So you do your loop cut half and half, perpendicular to each other. Let's go into bevel. Select all your outside vertices. So in edit mode, in vertex selection, bevel, select all your corner vertices. And then let's just bring it in just a bit. So I'm at about 1.0 something. Okay, and then let's go select all your vertices except the ones that you just beveled. So all your vertices in the middle of the edges and then the center vertex. Okay, and let's just raise it up. I'm gonna go 7. Just there's no reason you don't have to be at 7, but you can. Okay. Let's go into object mode. Let's add a modifier. Subdivision surface. And under levels viewport, we're gonna go to number 2. And in advanced, we'll go keep corners. No reason other than I like to keep my corners on these modifiers, especially with these type of geometries, but you don't have to keep corners. Okay, so remaining in object mode, you go File, Export, FBX. This should be easy. Everyone's done this a whole bunch of times. Just remain with selected objects. Name it whatever you like. And then for up, I'm going to use Z up because that's how we have it in Rhino. So export FBX. And then in Rhino, bring it in. It's going to ask you prompt to scale on import. I'm going to say yes, and then open import meshes as sub D surfaces. Okay. And then I'm going to press OK. Scale FBX geometry by 0.01. Yes. And then here it is. So this one, I'll color it something else just so everyone can see it. Let's just make it yellow. Or actually something that's more discernible. Let's make it green. And then you type 2 NURBS. So delete import object, no, it's just a habit, but faces, I want them packed. And then let's just convert it. And then in my selection filter, I'm going to press Shift up here and select polysurfaces only. So you keep Shift pressed down and select polysurfaces. When you click on this, it'll select just your polysurface. You move it over, and then you'll see it's one open polysurface, means it's composed of a bunch of surfaces. So you can select that and type explode. And now you have all of these different surfaces. Okay, does everyone have this? So isolate it a bit more. Okay, so let's bring this surface in. So same as what we did up here, we're going to bring surface, right click, set multiple surfaces. Okay, this is important. Set multiple surfaces, select all of them, and right click. And it'll set all your surfaces. Okay, and what I want to do now is I want to, let's hide what's in Rhino. So just select the model, the NURBS model in Rhino and type hide. Okay, so now you just see your surfaces that you brought in. So let's divide the surface. So I'm going to press type isotrim. Put your surface in here. And then I want to divide it. But I want to divide it in U and V direction. So same as what we did before, we're just repeating it. And then the domain will be the surface itself. And then the U count and V count, let's just go for U count, let's go 10. Make a copy of the slider bar. So put 10 into U count. Now I'm going to put 1 in V count. And so it's not giving me any surfaces. And what could the reason for that be? Let me see. Okay, reparameterize. No. Graft. No, it didn't work either. Where is it? Okay, I'm gonna try one thing. So in your surface, right click, set multiple surfaces. Or actually, and before we do that, let's go back in Rhino, type show. Let me just work this out for a second. So right click on surface and we go set multiple surfaces, but we don't select the one in the middle. So you just select everything and then press Control and unselect the one in the middle, right click. And then I'm going to hide these geometries one more time. Oh, my V count is 0. So yeah, it won't do anything. So your V count needs to be at 1. So now you get 10 surfaces. We have a message. The surfaces seem to show up. Yeah, thank you, JS. Who's JS? JS, what's your name?
Sorry, that's me.
Okay.
Jesse.
Okay, thanks, Jesse. Appreciate that. Yeah, please, if anyone ever catches anything, just let me know. Okay, so let's hide the surface component that we brought in. So preview off. And now we can see isotrim doing its thing. Right, and then let's look at a new component here called dispatch. So let's put surface into list. And then let's look at what this is doing for us. Geometry. So list A gives us this. Again, I want to hide isotrim. List A will give us a certain amount of strips, but if I put list B into the geometry, it gives me the other one. So it kind of alternates. So I'm going to show dispatch. And here you can see the contrast of the colors. So it flips between the lists. But one of the things I want to do here is I actually want all my curves to go like this, right? I'm trying to create a support here. So I want all my curves to go in this direction. So this is where we actually need to do some manipulations. Can everyone see my screen?
Yes.
Okay, do you see? Okay, something just happened to my screen here.
Yeah, it's purple.
Give me a second. Okay, there we go. Share it one more time. How's that?
That's good. It's not
Okay.
purple.
All right, so I want to change the direction. So mainly what I'm trying to do, and I'm just going to hide what I've done here before. What I'm trying to do is create this. So here you can see how your supports go from one end to the other. Now, this is a really important step. And I think today I'm just going to cover this, and I'll give you a recorded portion for the rest of it. But I'm just going to hide this code here. We have this geometry. Now, the strips are not aligned to how we want them. So we actually have to go in and we have to manipulate the strips. So in Rhino, let's show the underlying geometry. In Grasshopper, I'm going to select this green button. So only draw preview geometry for selected objects. So it's not distracting me. And I'm going to select the whole thing. And I'm going to type a command called dir for direction. Okay, so this is where it gets a little bit tricky. And I need you guys to follow along with this. So, and you know what? I will send this out in the chat as well. So to swap UVs, the red should be perpendicular to naked edge. We'll look at what that means. To flip hues, white arrows should be pointing inwards. And to flip these, white arrows pointing right to left. Okay, so just keep this list handy for you guys that I just sent on Discord. And let's have a look at what this means. So you see up here, it says select object to flip direction. Press enter when done. Now it's saying mode is flip normal. So right now it's showing us all the normals. So my normals are all pointing up. They're all in the same directions. So I don't need to do anything to that. So I'm going to go next. So next mode is swap U and V. So the red needs to be perpendicular to the naked edge. So what does that mean over here? So if you can see in here, it means the red is perpendicular to this naked edge down here, right? So this is okay. I don't need to do anything to this. In this case, the red is also perpendicular to naked edge. In this case as well. Let me actually change my display color. You know what? I'm going to exit this for a second, just so this is not confusing for you guys. I'm going to change this to white, or no, I will change it to gray. Okay, so one more time, select everything, DIR for direction. So we are in swap UV. So red needs to be perpendicular to naked edge. So in this case, it's not. So I'm going to click it. See, when you click the red button, it changes direction. So here, this direction is incorrect. This direction is correct. I need it to be perpendicular to the naked edge. So I fix this one. Over here, the red is perpendicular to naked edge. Yeah, so that's not correct. That's correct. Perpendicular to naked edge. Here, it is not perpendicular to naked edge. Now it is. So the red is perpendicular to naked edge. If anyone has a question about this, please stop me. Because this, I know this gets a little bit tricky. This is correct. This is correct. This one here is not correct. So I'm going to click this. Now it's perpendicular to naked edge. Perpendicular to naked edge. This one is not correct. So I'm going to click it. Now it's perpendicular. This one is correct. This one is not correct. So I'm going to click it. Now it's perpendicular to naked edge. And the rest of them, this one is not correct. So I'm going to click it. Now it's perpendicular. This is correct. This is correct. This is correct. This is correct. Now they're all correct for U and V. Now let's go to the next mode, which is flip U's. So the white arrows should be pointing inwards. So in this case, it's not pointing inwards. So we click it. Okay, let's see. As long as it's going in the right direction. Yeah, let's just make it go pointing inwards. This one, let's try to flip it. No, it's not correct. Okay, let's come back to the flipping of the U's. Yeah, because it's flipping the green. That's not the one we want to flip. Okay, let's go to the next one. Mode flip U. We're going to go into the next one, which is flip V. So V, white arrows need to be going right to left. So this is going right to left. Right to left, that's correct. This is not going right to left, and that's flipping the wrong one. White arrows pointing inwards. Okay, give me 1 second. Let me try to figure this out. Flip U. I don't want the green flipping, so let's go flip V. Right arrows, right to left. Okay, so right to left, that's correct. Right to left, right to left. This one needs to be flipped. That is not correct. So red perpendicular to naked edge. Next mode. Give me a second, guys. I need to figure this out for a second. Colors are not correct here. So V. That's correct. Next mode. Flip U. Right arrows pointing inwards. Okay, that's correct there. That's correct. That's correct. Is it giving me green? There. That's correct. We'll flip V. Next mode. Next mode. That's correct. For swap U and V, red perpendicular to naked edge. and then flip U, white arrows pointing inwards. Inwards, okay. Nope, that's not correct. Right, so flip V, right arrows right to left, 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 right to left. This one is not correct. Okay, well, I'm gonna see what that has done so far to our geometry. So I'm gonna hide all of this. Yeah, so now you can see the geometry supports are starting to go in the correct direction. But there's still some error over here. So we know that the U and V's are mixed here. Here, they're a little bit mixed. Here, they're a little bit mixed. Okay, let's try to figure this out. So show. Did anyone
I have
get
a,
it?
I have
Was
a
it?
question.
Yes, Zilla.
So I'm only able to click like one set arrow. Like I'm only able to click white arrows, and that's the only thing that I can change. I can't change like red or green arrows. Is there like a setting or something specific we have to do for that?
Yes. Give me 1 second. Let me show you that. So when you type dir, you press enter, you have to go next mode in order to get to the next arrow. But there's certain arrows that you have to press in certain locations, right? So I'm just going to diagnose, for example, with this one. This is correct. I don't need to do anything here. This is correct. This one, there's something going wrong with this one here. So when it comes to flip V, your white arrows should be going right to left. So that's actually correct here, but this one is not. See how it's going left to right on this one? So this is the one, yeah, there. That fixed it. So flip V in this direction. So right to left, right to left, right to left. So the arrows that you're able to click to answer your questions or not is depends on the mode that you're in, flip V. And it always takes me a few tries. Like I have to go in and out of the model and then press dir again to make it work. So now this flip V is working, for example. So I'm able to like flip the direction going right to left everywhere. So right to left for the white arrow, right to left, right to left, right to left, right to left, right to left. And then let's try this one. Yeah, right to left, 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 right to left. Okay, so flip V is okay. So we're gonna go next mode. I don't want to flip the normals. Normals are all good. Next mode, swap U and V. Red should always be perpendicular to the edge, which in my case it is. So red is always perpendicular to naked edge. We just make sure of that, and it's fine. Fine, 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 fine. Okay, now we try one more time. Flip U's. So white arrows should be pointing inwards in flip U's. That's the trick. Yeah, so pointing inwards, good. Pointing inwards, pointing inwards, pointing inwards, pointing inwards, pointing inwards. That one was not correct. Pointing inwards. This one, pointing inwards, pointing inwards, pointing inwards, good. Pointing inwards, and now they're all pointing inwards. Okay, let's see if that worked. So I'm gonna get out of flip direction, basically right click, and it should take you out. And then now we have a look at our support geometry. So let's hide this geometry in Rhino, and now you can see the strips are all following in the correct direction. So I don't know why this is, but this is my experience. Every single time I have to work with swapping U and V's, flipping U's, flipping V's. The rules are what I typed out in Discord, but it always takes a couple of tries to go in and out of the model, pressing DIR again, and making sure the flipping is working correctly. Okay, so I'm going to stay here and record the rest of this tutorial. The class, if you guys, it's 12:19. You can head out if you like, or you can stay with me and ask questions. So, but I will provide you this recording, so you will have what I do here. So if you need to leave, it's 12:20. It's totally up to you. So I'm going to continue here. Okay, sorry, we have some charts. Okay. Yeah, thank you, everyone. Okay, so in Grasshopper, I'm going to get out of this preview geometry mode because I want to just have a look at everything I'm doing. Just turn preview off. I've got this as my geometry at the end. And then here's the neat part. What you can do now is let's bring in extrude. Okay, so let's give it a Z direction. And let's extrude this geometry. See, now it's extruding. Now you actually have some thickness for your support. So what is my factor for Z? It's 1. Let's reduce it. So I'm going to go 0 dot 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 0.05 dot 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 1. And let's see how that works. So here you can actually affect the geometry the way you want in terms of the thickness. So now I have my supports, and you can actually flip between supports. You can dispatch. You have list A, which basically skips every other ISO trim, and then list B, if you put that in, it just flips to the other one, right? So in our case, if I had to look at this, if you look at this corner here, it's not joined with list A, but if I select list B, it's joined, and now it's turning into an actual pavilion. It's turning into something you can actually like build and make. Okay. So the next one we're going to bring in is let's copy all of this over. So up to ISO trim, just copy that over. In Rhino, we're going to go show geometry. And then for surface here, right click, set one surface, and bring in this middle surface, this middle guy, which currently is lonely. And then we select all these surfaces and we type hide one more time. And let me just reveal the ISO trim. You can see how it's starting to work with this middle geometry. So it was a bit of a window that we cut out for ourselves. And now we're just gonna try and work with it. Okay, so what I want to do is I want to create some openings in here. So let's evaluate surface. Let's bring in MD slider, because that gives me sort of the evaluation. This is something you guys have already done. Let's bring in area. Distance. So I'm going to put evaluate surface in point B. And then the centroids from area into point A. Okay, and what I want to do is I want to scale my ISO trim. So put this into geometry. Let's use the centroid of each of these panels that I've created. And then for factor, we can go, let's say 0 or 0 dot 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 0 0.5, actually 0 0.05 dot 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 1. I don't want to go bigger than a factor of 1 because that would mean that the window gets much bigger. So here you can see now these windows are developing inside of these things. But let's make this a bit more compelling. So in divide domain, let's just, for simplicity's sake, let's take the U count to 5 and the V count to 5. Okay, and then let's hide everything, preview off other than scale, so you can see what's going on here. And maybe let's even bring back the ISO trim. So preview on an ISO trim, so now you can actually see how it's scaling, right? So this gives you a parametric sort of version to create these openings in here. And, you know, with the class like Raymalene taught with your attractors, you can actually now start using attractors to affect your scaling. So definitely give that a try. Okay, so coming out of here, now I want to loft between each of these cells and the window, because I want to now create a frame, a picture frame. So I'm going to go loft, and I'm going to take curves. Again, you don't have to use the curve component, but I like to keep things organized. So I'm going to take curves from this one, and you can see what's highlighted. Let's copy the curve component. Let's bring in the curves from isotrim. That gives us the outside curves. And let's loft these. So let's put them into a merge. So curve 1 into data 1, curve 2 into data 2, remove data 3, result into curves. But see how it's kind of all over the place. So remember what we have to do here. So right now it's a flat list. I'm going to click here, and instead of using a draft component, I'm just going to go draft. And now you have these neat picture frames. See? You can now hide your scale component. Let's hide the isotrim component. And now you can see these really neat lofted window picture frames. And again, these can be affected by attractor curves. And now let's bring in another extrude component. Let's put the loft into this. Let's use the same unit Z that was in extrude here. Let's hide up to curve, preview off. And now let's use a merge component to bring in what we extruded from the first one, what we extruded from the second one. And now you have a pavilion with openings for sunlight. Everything is data-driven. You can extract geometries, you can get it ready for fabrication. There's no clashes in this model. Everything works together. Any questions? All right, that was the end of the tutorial. You guys can, thank you for staying, whoever stayed, appreciate it. And I'm just gonna add one little bonus scale component here. You can log off. I'm gonna finish the recording and I'll share it with you guys. So, okay, so now my scale right now is being affected by this number slider. But what if I want it to be affected by the distance in this MD slider that I originally set up? So let's bring in a domain, a bounds component, attach it to distance. Now this gives me my smallest distance and my largest distance between evaluate surface point, so where this MD slider is, so where this plane is, and where the centroids are of all my panels, right? So I'm evaluating that distance. So we've got bounds. Let's remap the numbers. Let's put value from distance, because that's what I want to remap. My source is these bounds. So my smallest and my biggest one, and then I'm going to construct domain from this. So my start, let's just say 0.5, actually 0, dot, 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 0.5, dot, 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 1. Make a copy of it. Domain start, domain end. Make domain start maybe a little bit bigger than domain end, just to see what happens. Construct domain goes into target, because I just want my numbers remapped within this domain. So within 0.9 to 0.4 only. I put mapped into factor, and now see what happens. See, now you can get bigger and smaller windows in different areas based on where your MD slider is. So you can take your domain start to be smaller, the domain end to be bigger, and then you can actually move your MD slider around to affect these geometries. So in a way, it's kind of like an attractor, but you use a slider to affect it. If you actually use attractors, you can have a different workflow in here as well. So that was the bonus thing I wanted to show with the remap numbers. This is just something for you guys to know. Yeah, that's pretty much it for today.